So the other day in section 3.5, we started going over the sum formulas for the sine and the cosine. And one of the things I showed was that once you know the sum formula for, say, the sine, you can get the sine formula for the difference, that is the sine difference formula, by replacing beta by negative beta. Now if I do that, then here alpha plus negative beta is the same thing as alpha minus beta. Cosine of negative beta is the same thing as cosine of beta, so that negative doesn't do anything, it kind of disappears. But here, sine is an odd function, so that negative factors itself out, and I get this formula. Sine of alpha minus beta is all this. You can play the same game with the cosine. Cosine of alpha minus beta. Cosine, again, is an even function, so I can get rid of the negative here. With the sine, the negative is going to factor out as a -1, so that becomes a plus. Now, if you take a quick look at this, one thing you'll notice is that the sine function, the signs here match. Minus, minus, plus, and plus up here. With the cosine function, they're opposite. Plus and minus, minus and plus. So, something to keep aware of. But let's take a look at a couple problems in the book that play off of this, and that will start with problem number 24. It's a nice application of this. There you go. So problem 24. Sine of 20, cosine of 80, minus cosine of 20 times the sine of 80. Yeah, sine of 80. Now the question asks you to find the exact value of this. So hopefully you're not going to reach for your calculator, and that would give me a decimal value. But if you start looking at this and looking at all our different formulas, the sine sum formula, sine difference formula, cosine sum, and cosine difference, well, the only one of our formulas here that involves a sine and then a cosine and then a cosine and a sine is up here with the sine sum and difference formulas. Which one does it look like it lines up best with? Looks like it's sine of alpha minus beta, right? So what's our alpha in this case? Yeah, thank you. Alpha minus beta is going to be 20 minus 80. So this is your alpha, that's your beta. So, okay, that looks pretty good. So equivalently then, kind of running the formula in this direction, this is going to work out to sine of 20 minus 80, which is sine of -60. Let's use one of our identities right here. How can I rewrite the sine of -60? Negative of the sine of 60. Good. Just bring out the negative. Negative is sine of 60. Good. So that's our even-odd property. And now we have to think a little bit about the unit circle. What's the sine of 60? Yeah, root 3 over 2. So overall we end up with negative root 3 over 2. Okay, not too bad. Just requires that you know these formulas. So let's try a similar one. Problem number 26. Was there any questions or thoughts on problem number 20 before we move on to 26? Cosine. Yes. Yeah, it lined up pretty nice. I mean, we had a minus here, sine of something, cosine of something, cosine of something. It all lined up pretty nice, right? So, for instance, problem 26 gives you the cosine of 40 times the cosine of 10 plus a sine of 40 times a sine of 10. Now, does that line up real well with our sine formulas? No, because here you have a mixture of sines and cosines, cosine and sine, so that doesn't look too good. Let's scroll down a little bit to the cosine. Cosine looks a little bit better, but is it the cosine sum identity? It's the minus one, right? Because the plus here goes with a minus here. So this is cosine of what minus what? Good, 40 minus 10. Again, this is your alpha, beta, alpha, beta. 40 minus 10 is the same thing as a cosine of 30. Don't make people do all the work here. Cosine of 30 is root 3 over 2. Yeah, 30 is a pi over 6 angle in radians. 30 degrees is. But yeah, the answer we're looking for would be square root of 3 over 2. Okay, so hopefully a couple friendly problems to kind of get us back in the swing of things. All of these are relying on these cosine sum and difference formulas. So let's move on and try a couple harder ones then. We're going to start with, let's see which one. Problem 36. So problem 36 gives us some information. They're going to ask us for a lot of different things in problem 36. I'm not sure we're going to do all of them, but maybe we'll do one or two. They're going to ask you for the sine of alpha plus beta and the cosine of alpha plus beta, and there's a tangent and a sine of alpha minus beta, etc. Really, the big thing here is to be able to set this up, to set up some triangles so that we can find the sine of alpha or the cosine of beta or whatever it is we need. So in problem 36, they start by telling us a couple things here. They tell us that the tangent of alpha is 5 over 12, and that alpha is an angle in the third quadrant. In other words, pi is less than alpha is less than 3 pi over 2. Okay, let's see if we can't draw this angle. So I'm going to draw an angle that's in the third quadrant. Really, I'm drawing what's called the reference angle here. And I want some angle in the this quadrant, so we'll do it roughly like this. It doesn't have to be to scale. The one thing that is kind of important, though, is that you have it drawn in the right quadrant. So here's your alpha, some third quadrant angle. And let's see if we can't label the sides. Now, the other day we went over so, ka, toa out of sheer convenience. Formally, that doesn't get introduced until section 4.1, but we went over it early just because it's really convenient. What's the Toa part? Tangent is opposite over adjacent. Okay, so if this is our alpha, then this would be the opposite side, right? So it'd be 5, and this is 12, that's your adjacent side, but there's something that's not quite right here yet. We're in the third quadrant. So in the third quadrant, those are both negative. All right. Let's finish this off here. Let's come up with a hypotenuse. All right, negative 5 squared plus negative 12 squared is 169. Square root of 169, 13. Yeah. No, good question. The hypotenuse is always going to be positive. Okay, when you draw these things, the hypotenuse will always be positive. Does anyone need me to write down the Pythagorean Theorem here? Are we good on that? Okay. Let's just leave this aside for a second. They give us some information about the other angle. They say that sine of beta is negative 1/2. So sine of beta is negative 1/2. And that beta is an angle, again, in the third quadrant. So pi is less than beta is less than 3 pi over 2. Why is that telling me that this is in the third quadrant? Yeah. Mm-hmm. Good. So it's an angle between 180 and 270 degrees. That has to be in the third quadrant. So let's draw a third quadrant angle that satisfies this.
Will they ever be in separate quadrants?
Oh, they can be in separate quadrants. Yeah, this one just happens to be in the same quadrant, but they don't have to be. In fact, if you'd like, maybe the next one I'll choose so that they're not. Okay, let's go back to sine. What was sine? SOHCAHTOA. Sine was opposite over hypotenuse. So the opposite, let me regard that as being negative 1 over 2. There's your opposite, there's your hypotenuse. So negative 1 over 2. And at least, now this one I will write down the Pythagorean Theorem here. It's going to be negative 1 squared plus b squared equals 2 squared. So 1 plus b squared equals 4. B equals 3. What are my possibilities for b? Perfect. Plus or minus square root of 3. Perfect. Exactly what we wanted. Which one do I have to pick, though? The positive root or the negative root? Negative root. Good job, because we're in the third quadrant. All right, so there's beta. We've got everything we need. We can answer any question they want to throw at us right now. So let's take a look at the first question that they do throw at us. They ask us for the sine of alpha plus beta. Okay, well, there's a formula for that. We know that. It's sine of alpha, sine of alpha cosine of beta, plus cosine of alpha sine of beta. And let's just go look at our triangles and fill in all these different things. Let's start with the sine of alpha. What's the sine of alpha? Here's alpha. Sine was opposite over hypotenuse. So opposite over hypotenuse. There you go. Negative 5 over 13. And now let's do the cosine of beta. All right? Same kind of thing here. Bianca, cosine of beta would be so cosine is adjacent over hypotenuse. Perfect. Negative square root of 3 over 2. And let's keep going. Thank you. Cosine of alpha. So now we're back to this triangle. What's cosine of alpha here? All right, negative 12 over 13. And finally back to this triangle for the sine of beta. Sine of beta, well, we already know that one, right? It's given to us. It's negative 1/2. So overall, I get 5 square roots of 3 over 26 plus, I'm going to keep this as a common denominator, 12 over 26. So 5 square roots of 3 plus 12 over 26. You don't have to do that. You could reduce that to 6/13. I don't care. At this point, I'm really happy that you got here. The tough part for these problems is to set up these two triangles, is to get those things right. So we're going to definitely practice that at least one more time.
So on the exam, kind of like a problem like this, would it work at different points for each setup, or would it be just one whole setup?
So in problem 36, they ask you this, they ask you the sine difference, and they ask you a tangent. My way of thinking, once you got the triangles, you can answer any question. For instance, if you're asked like cosine of alpha plus beta, well, it's just filling in a different formula. So, when I ask you a question on the test like this, I'm only going to ask one part of it. I'm not going to ask all four. So that way it keeps it a little bit more sane. So this would be cosine alpha, cosine beta, minus sine of alpha, sine of beta. And again, it's just a matter of filling in the right values to finish the problem from there. The big part of it is getting the triangles written down. Oh, it's a great exam problem. Yeah, I can pretty much guarantee one will be there. Yes. Do you want to try one right now, or do you want me to do one more? I mean, I'd be happy for you to do one right now. That'd be great. Do one? Okay. So let's. Why don't you try problem number 38? So let me get that up here for you. We'll get you a little bit of a start, and then Mod and I will walk around and try and help you out. So 38 gives you the cosine of alpha is 1/2, and alpha is between negative pi over 2 and 0. What quadrant is that saying things are in? Yeah, it's in the fourth quadrant. Sine of beta is 1/3, and beta is in the first quadrant. 0 less than beta, less than pi over 2. So let's draw those respective angles. I'm not sure, you guys have probably looked at last year's test more recently than I have. Did I also draw like triangles or axes here for you for these problems? I might have, not sure. Oops. So this would be beta, and there's your alpha, or you can think of alpha here. Okay, thank you. So try labeling those, and then the last one we did the cosine, or we did the sine sum identity. This time we'll do, say, the cosine sum identity. So we'll do part B here. Let's figure out cosine of alpha plus beta. The first thing you need to do is label those triangles. You're going to have to use the Pythagorean Theorem to finish off finding the sides of these triangles, and then move forward from there.
Yeah, I just have to slow down. I have a headache. So I get it. It's 2 square root of 2. But how does, so like from that fraction, I always get confused on how to turn it to radians. So is it 180 over pi? I would multiply that by 0.8 and 180 over pi and then just add pi. Right, but from decimals, how do I get it to that? To 2 square root of 2. You know what I'm saying? It's the same as this calculator. So. Because I tried fractions and it just still did that 2.8. Okay. Yeah. Right, because you showed me that. I was just setting it up. Cosine is CAA? It's over up. I thought it was cosine is adjacent. See, I'm setting everything up. So then the opposite is 3. Sine is 1/3 and cosine is 1/2. That's what I got when I did everything. Why? Because it's negative, so you have to square root it. Okay.
Wake up. Okay. Come on. Okay. Let's take a look at this one closely. 1/2 here for the cosine is the adjacent side over the hypotenuse. From the point of view of alpha, this would be your opposite side. Then this has to be the hypotenuse. And this has to be the adjacent side. That's kind of like what's left over after you determine the opposite and hypotenuse. So the adjacent side was 1. The hypotenuse is always positive. That's a 2. Now we need to figure out the opposite side. Let's just call that b for the moment. So filling in the Pythagorean Theorem, I get 2 squared equals 1 squared plus b squared. Or 4 equals 1 plus b squared. 3 equals b squared. Plus or minus square root of 3 for b. which choice am I going to make here? Positive root or negative root? Negative root, because I'm below the x-axis, so negative root 3. Let's move over and calculate b over here. So this time, let's see, we know that sine of b is 1/3, so that's going to be your opposite over hypotenuse. So the opposite side here is 1. The hypotenuse is 3. Again, I'm calling that b. You can call it a or x or y or whatever letter you want. 3 squared equals 1 squared plus b squared. Subtract 9 minus 1, I get 8 equals b squared. Some of you I saw were really conscientious and broke that down into 2 root 2. That's great if you do. I'm not really so concerned about it if you don't. The important thing we realize here is it's 2 root 2. Is that going to be positive or negative? Positive. You're in the first quadrant. All these sides are going to be positive in the first quadrant. Let's fill in our formula now for the cosine sum. We get cosine of alpha. Well, we started out with that. Cosine of alpha. In fact, let me rewrite it down here. Cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. And let me do something that I saw a few of you do, and I don't want you to do it because it's wrong. Your next step down here, you wrote cosine of 1/2. And then cosine of 2 root 2 over 3. Well, that's wrong. The cosine of alpha is this. You're not taking the cosine again. So you're done with that. So really what you should be writing is be a 1/2 and times 2 root 2 over 3 minus sine of alpha. Sine of alpha, that's going to be your opposite over hypotenuse. So negative root 3 over 2 times sine of beta, which is going to be 1/3. We already know that. That's what was given to us, so hopefully we can get that one right. When we multiply these together, I'll get square root of 2 over 3. Minus and minus become a plus. Let's see. Square root of 3 over 3. No, square root of 3 over 6. There. If I didn't do the cancellation, I could have kept common denominators. I would have ended up with 2 root 2 over 6 plus square root of 3 over 6, or better yet, 2 square roots of 2 plus square root of 3 over 6. This is a nice exact answer. That's what I'm going to be looking for on your exams, is exact answers. Okay. How are we looking on 38? Okay there? All right. Maybe take a look at the video at some point at home. Rewind it a couple times. Make sure you got this one down.
So we don't have to break it down to 2 root 2. We can leave it up. Plus or minus.
You know, there's a couple of forms of the answer I'll be happy with. This is fine right here. This is fine right here. If you've got common denominators, might as well add them. I'm not going to mark you wrong if you leave it like this. Although I'd find it a little bit funny that you didn't cancel if you're leaving it like that. But whatever. This is a long enough problem that I don't want to ding people for not rationalizing a denominator. All right. Once you have these things set up, I mean, you can answer all kinds of different questions. One thing that we haven't gotten around to yet would be the tangent sum and difference formulas. But once you have these, you can calculate, like I said, pretty much anything you need. All right, last chance. Are we okay on that one? Just about, just about. Yeah, look, they're going to take some practice, which is, you know, it's okay. It's why we're doing a couple extras here today. Let's do one last one. Trying to decide if I want. Problem number 80. 80. Yeah. Still the same section. Let's make it not look scary then. So problem number 80. 80. Cosine of the tangent inverse of 4/3 plus cosine inverse of 12/13. Realistically, what they're giving you is another cosine sum formula problem. When you take the inverse trig function of a number, you're going to get an angle. So this is an angle, call it alpha. This is an angle, call it beta. So that's what we're starting out with. We're starting out with the sum of two angles. We're going to end up drawing some more triangles again. So, by the way I'm writing this, alpha is equal to the tangent inverse of 4/3. Okay. If alpha is the tangent inverse of 4/3, then another way to write this is the tangent of alpha equals 4/3. That's what this is saying. These are two different sides of the same coin. Alpha is the angle whose tangent is 4/3, or tangent of alpha is 4/3. Either way. But at this point, we can draw this angle. So let's do that. Let's draw this. Now, they don't have any clues like the last problem, but I know that tangent is positive in the first quadrant, and what other quadrant? Third quadrant. Good job. So I'm going to take the easier route and draw a first quadrant angle. So here's alpha. Yes. You know, I'm not sure exactly how it would affect it if we drew a third quadrant angle. But the tangent inverse is not going to give you a third quadrant angle anyways. So if you want a positive tangent from the arctan, from the inverse tangent, it's going to be in the first quadrant. So we really don't have much choice. What can I label these sides? Michael, what would these sides be?
Jason.
So what's this side?
That'll be adjacent.
Well, that'd be opposite. So that'd be a 4 and a 3. Does everyone recognize these two numbers? They form a nice Pythagorean triple. 3? Good. 3 squared plus 4 squared equals 5 squared. Nice Pythagorean triple there. So, okay, cool. We got that one in place. Let's see about the other one. Cosine inverse of 12 over 13. So that's our beta. Beta equals cosine inverse of 12 over 13. So cosine of beta equals what? 12 over 13. So try and draw beta. Now remember, let me write it down again here. So, ka, toa. What sides am I working with when I'm working with the cosine? Cosine is what over what? So here's beta. Beta is going to be, let's see, what sides can I label for beta?
12, hypotenuse 13.
Perfect. So from the Pythagorean Theorem, we can solve for this unknown side. 12 squared plus 5 squared is 13 squared, so a nice Pythagorean triple. And we're going to choose the positive root because we're in the fourth quadrant, but there's your, or first quadrant. There's your beta. Let's fill this in now. So cosine of alpha plus beta is cosine alpha, cosine beta, minus sine of alpha times the sine of beta. And all of these are nice, neat fractions. So see if you can't fill them in for yourself. The range of the inverse cosine is between 0 and pi. Yeah, very good. So the only place that it could be, positive then would be in the first quadrant.
Still kind of alpha. Why it's in the first? If it's in the third, then when you use the cosine.
Well, it would make a difference if it was in the third, but the range of the inverse tangent is pretty much the same as the range of the inverse sine. It's between negative pi over 2 and pi over 2. So it has to be in quadrants 4 or 1.
That's something we kind of need to pick up on and memorize.
Yeah, it's
Quadrants.
yeah, it's
It's going to be a huge help rather than trying to figure out.
Now, just kind of a quick and dirty trick for you. If you're stuck and you're like, oh my God, I just can't remember. If you're blanking out on a test and you're freaking out, here's what you can do to kind of remind yourself where these things are defined. So let's put our calculator in degree mode for just a minute. So over here to degrees. And then let's take kind of the extreme values that we can for the inverse sine, inverse cosine. Let's do the inverse sine, so second inverse of negative 1. And I get negative 90. If I did the same thing with a positive 1, then I'll get positive 90. And that's telling me that the inverse sine has as its range the values between negative pi over 2 and pi over 2. So you're in the fourth quadrant. Now when I repeat that with the inverse cosine, then I get 180 degrees and 0 degrees, really. So inverse cosine has as its range 0 to 180. So yeah, so it's a little trick here. So you know, if you're in a pinch, this is how you can do it. Tangent, inverse tangent is pretty much the same as the inverse sine. The only thing is you can't actually get to negative 90 and 90, but that's the only difference. Okay. All right, but good question. Thanks, Brittany. Jeff, maybe you can help us out. What's the cosine of alpha here? 3/5. Cosine of beta? 12/13. Good. Want to keep going? All right, sine is 3/5. No, wait, 4/5. You said 4/5. 4/5 and 5/13, right? All right, so let's multiply that together. It's going to be 36 over 65 minus 20 over 65, and I get 16 over 65. Yay. All right, so this is kind of like a third or bonus problem on top of the previous couple that we just did like that. I know these are long and challenging. That's why I limit myself to 6 or 8 of them on an exam. All right. Let me give you a little bit more homework. Yeah, I know. You'd feel really bummed and cheated if you didn't. Uh, let's see. So, oh, I don't want.
So should we
Cancel.
expect a lot of 3-5 on this?
There's a lot of good problems. I mean, some of them I think are pretty easy.
This is
Um,
not so good.
yeah, I know. This is the one that's not necessarily that easy, but this one's an easy one, right?
Yeah. And is it gonna? It's gonna
These are
match
good ones.
roughly for like the past exams. Like that's
Uh,
the study guide.
you know, I don't really look too much at the past exams. I just, I pull problems out of the book. I'm like, oh, I remember doing problem 26 in class, so maybe I'll do problem 25. We did problem 36. Maybe I'll choose problem 35, or maybe I'll choose problem 36 as well. So it just doesn't matter. So if you think about the problems we've done in this section, we've done some like this. If I gave you one like this, I'd probably give you the hint that, gee, pi over 12 is pi over 3 minus pi over 4. Hint, hint. And then you're going to use, hopefully, the sign difference formula. That's what I'm expecting you to use. One thing I see all the time, if I ask people to calculate sine of pi over 12, and I give them that hint, and they use the hint, and they go, okay, cool, sine of pi over 3, minus pi over 4. And then they break it up like this. They treat it as if you can distribute, as if it's sine of pi over 3 minus sine of pi over 4. And that's not true. We have formulas for this. This is why we introduced the sine sum and sine difference formula, and same thing with the cosine, is because you can't just distribute there. It just doesn't work. So that's where you have to go back to these formulas and work with those. For home, yeah?
Do you mind if we convert degrees?
If you're doing one like this, it might make it easier to see if you're doing one like this. If you look at that and say, gee, that's sine of 15 degrees, and oh, 15 degrees is 60 degrees minus 45 degrees, I can't really complain. I mean, as long as you give me, the right answer when it's all said and done, then no, I certainly understand and appreciate the desire to work in degrees. It's a lot clearer. Most people wouldn't look at that and go, gee, that's this. And I don't expect that. For a problem like this, I would give that kind of a hint. So, yeah, but if you want to do it in degrees, that works too. Now, some of this I assigned last time. Some of it's going to be new. For homework, try 9 through 27. Then,
Just more practice.
let's see. No, I'm not. I want to take a closer look at this. Through 27. 31 through 37. (47) through 47 through. Let's see, I don't want to assign too many of these. Let's go up to 55 and 71 through 79. You can skip wow. On the next page, you can skip 81 through 111. There you go. Hey. I'm messing with you guys a little bit. All right. Enjoy. It's 3.5 still. So section 3.5.